AI video and 3D systems are starting to move beyond fixed outputs. They can extend an ongoing scene, preserve a person's identity by correcting only a few keyframes, and generate objects with hundreds of explicit parts. That matters because the bottleneck is shifting from raw synthesis to controllable, scalable structure, bounded memory, long context, and constraints that remain stable over time. Across work involving Alibaba's Helios and Qwen models, the common strategy is to separate planning from correction. We'll see how that enables 1,000-frame editing, reliable faces, and 300-part 3D assets. Let's explore the first paper, Infinity Edit, Infinite Video Editing with a Lightweight Edit Ignition Adapter. Infinity Edit defines infinite video editing as generating each future video segment while applying successive natural language edits, rather than rewriting a fixed clip frame by frame. The system attaches a lightweight Edit Ignition Adapter to the frozen 14 billion Helios distilled streaming generator. 3 attention modules provide complementary control. History cross-attention anchors the new chunk to prior frames. Temporal causal self-attention propagates information forward, and edit cross-attention injects the instruction. The adapter activates only for the first chunk after an edit, while Helios continues subsequent chunks using a sliding history window and a reset anchor frame, preserving long video generation with bounded memory. Training uses synthetic triplets from Ultra Video, detailed instructions expanded by Gemini 3 Flash, boundary frame editing with Qwen Image Edit 2511, and target synthesis through WAN 2.2i 2VA 14b, plus history corruption and a 2-phase mixture Gaussian flow matching curriculum. On a benchmark of 200 source videos evaluated over 3 editing rounds, Infinity Edit achieved a 0.7654 camera motion score, compared with 0.5494 for the pure Helios baseline, and scored 3.828 for edit faithfulness under Gemini 3.5 Flash judging. Its edit faithfulness standard deviation across rounds was only 0.023, indicating minimal degradation, and long video tests remain stable beyond 1,000 frames. The method targets open-ended use cases such as continuously restyling live footage or changing camera motion in an ongoing shot. Let's explore the second paper, Key ID Decoupled Drafting and Keyframe Editing for Identity-Preserving Video Generation. Key ID is a training-free framework for identity-preserving video generation that separates motion synthesis from identity insertion. Its reference-aware video generation stage uses OpenAI's GPT-5.4 for prompt enhancement, Ernie Image Turbo and Qwen Image Edit 2511 for the initial scene, WAN 2.2 with prompt relay for timeline-controlled video drafting, and LTX 2.3 for motion interpolation. Instead of forcing one diffusion process to satisfy detailed actions and preserve a face simultaneously, Key ID generates an identity-agnostic draft, samples local groups around 5 representative keyframes, applies face swap correction, ranks candidates with arc face, and interpolates the corrected anchors across the sequence. On the VIP 200,000 benchmark, Key ID reaches a face cur score of 0.633 and a face arc score of 0.630, improving over the strongest baseline TPIGE by 28.7% and 33.2% respectively, while achieving the best clip score of 30.9. In ablations, adding keyframe editing raises face curve from 0.279 to 0.596, while combining it with reference-aware drafting reaches 0.636 face curve, 0.643 face arc, and 30.9 clip score. For sequential actions, the system produces an 81-frame draft and a 121-frame final video, and earns a challenge score of 1.81 for second place in track 2, demonstrating that sparse identity correction can preserve facial fidelity without sacrificing prompt adherence or complex temporal actions. Let's explore the third paper, Megaparts Scaling Part Aware, 3D Object Generation to 300 Parts via Token-Efficient Autoregressive Modeling. Megaparts presents a token-efficient, autoregressive framework for part-aware 3D generation, addressing the memory and sequence length bottleneck that limits diffusion and conventional autoregressive methods to relatively simple objects. Its causal vector quantized VQVAE encodes each component with an adaptive length prefix, selected through a rate distortion objective that allocates more tokens to geometrically complex parts, alternating VQVAE optimization, optimal transport quantization, and stochastic gradient shortcuts stabilize the discrete representation. A fine-tuned Qwen 3 to 8 billion model then generates object-level and part-level bounding boxes, followed by local shape tokens in one structured sequence using context and tensor parallelism for long context training. The system scales to 300 parts and 256,000 tokens, trained with nearly 10 million part meshes and approximately 440,000 part-aware assets, while preserving explicit structure for editing and articulation. On part observerse Tiny, Megaparts records a text-conditioned FID of 43.40, outperforming Cube's 55.58, Trellis Text's 54.81, and Shape LLM Omni's 70.99. In held-out bounding box condition tests, it maintains a 0.77 success rate for objects with 200 to 300 parts, whereas diffusion baselines often fail from memory exhaustion. The pipeline uses Roblox's Cube as a tokenizer, starting point, Kimi-K 2.5 for geometry captions, and was profiled on an NVIDIA A800, positioning long context language model generation as a scalable alternative to diffusion for highly compositional 3D assets. That's a wrap on today's AI paper highlights. Thanks for watching.